Hello class. In this video I work example 1 from section 6.7, consumer and producer surplus, on page 97 of your note packet. Well, in example 1 we're given that the demand function is equal to this function of x on the right hand side of the equal sign, and the supply function is equal to this function of x on the right hand side of the equal sign. We're given, right, this has to deal with bicycles. We're given the equilibrium quantity, where quantity supplied equals quantity demanded of bicycles, occurs at the point 300, 160. 300 is the equilibrium quantity, 160 is the equilibrium price. Okay, so this is a horizontal coordinate, and this is the vertical coordinate in the coordinate plane in the graph of these two functions. And so x bar, the equilibrium price, is 300, and p bar, x bar, the equilibrium quantity, is 300, and p bar, the equilibrium price, is equal to $160. So here's the graph of the demand function, d of x, in red. Here's the graph of the supply function, s of x, in blue. And where those two functions intersect in the first quadrant, x is equal to 300 and p is equal to 160. Okay. The consumer surplus, which we're going to calculate first, as a reminder, is the area above this horizontal line segment to the right of 160 and below the demand curve d of x, right, where c of x is written in that area in the graph. Okay? C of s is written in that area of the graph. The formula for consumer surplus and producer surplus you don't have to memorize. They're given to you on the exam and they're given to you in the note packet. The value of the consumer surplus, I initiate CS, is equal to the definite integral from 0 to x bar, the equilibrium quantity, of d of x, the demand function, and we subtract from that value of that definite integral p bar times x bar, the product of the equilibrium price and the equilibrium quantity. So in this case, x bar is 300. The demand function d of x is equal to this inside the parentheses. And then the product of p bar x bar is 160 times 300. So first step, find the antiderivative of the function in parentheses. Well, the antiderivative, right, in finding the antiderivative of this first term, right, we use the power rule for antidifferentiation. We add 1 to the exponent and get 3, and then divide by 3. So this is the antiderivative of the first term of the demand function. The antiderivative of 250 is 250x, and then we have to evaluate this antiderivative at the limits of integration, x equals 0 and x equals 300. And then we subtract from that the product of p bar x bar, which is equal to 48,000 in this case. So this 48,000, or this product, right, is not inside the definite integral. It's external to the definite integral. So let's plug in the upper limit of integration. A little short on space. When we put in the upper limit of integration for x and our antiderivative, we have minus 0.001 divided by 3 times 300 cubed plus 250 times 300. Make sure you haven't made any mistakes. And then we have to subtract, remember we got to subtract, and then we put in the lower limit of integration for x. Well, when we put in 0 and for x in these two locations, each of those terms are going to equal 0, and so we're going to end up with 0 plus 0. And then we got to subtract the 48,000. Well, this in parentheses is equal to This first term is equal to minus 9,000. The second term is equal to 75,000. And 0 plus 0, you know, is 0. And then we have to subtract the 48,000. And now we simplify, right? Do that arithmetic, and we get 18,000 as the consumer surplus. Okay? 18,000 what? Well, right, it's got units. Well, X is in thousands, okay? So this is going to be $18,000. Okay? P, right? This is basically price times quantity, right? And so the price is 160, right? And quantities in thousands. And so the value of that consumer surplus, right, is a number in dollars. In this case, it's $18,000. And if I multiply 18,000 by 1,000, I can write the consumer surplus for this example as $18 million. So you can't forget the units, okay? At the end of the day, right, the consumer surplus is, if the currency's in dollars, the consumer surplus is going to be in dollars. If the currency's in pesos, the consumer surplus is going to be in pesos, okay? We have to do a similar integration, okay, in finding the producer surplus, right? The area above the supply curve and below the horizontal line segment, right, across from P equals 160, right, where I have PS written here. Well, from your note packet, the formula for the producer surplus is equal to P bar times X bar, right? That's equilibrium price times equilibrium quantity, minus the definite integral from 0 to X bar, right? The equilibrium quantity of the supply function S of X dx. And so now we got to substitute into that formula, evaluate the definite integral to get the producer surplus. So in this case, producer surplus, is P bar X bar, which is 160 times 300 again. And then we subtract the definite integral from 0 to 300 of the supply function, which in this case is 0.0006x squared plus 0.02x plus 100. Let me make sure I haven't made any errors. All these decimal points floating around, it's easy to make an error. And so 160 times 300, right, that's 48,000 again. And then we have the antiderivative of the supply function. So when I add 1 to the exponent, I get 3 divided by 3, right? This coefficient is divisible by 3. And so I have 0.0002 x cubed as the first term of my antiderivative. And then the antiderivative 0.02x, when I add 1 to the exponent, I get 2. When I divide by 2, that coefficient is divisible by 2. And I end up with 0.01 x squared for the antiderivative of the second term. And then the antiderivative 100 is 100x. And then we have our limits of integration from x equals 0 to x equals 300. And now we got to evaluate, put in the upper limit of integration in for x in our antiderivative, and then put in the lower limit of integration, which is 0. And so when we do that, right, we have the 48,000 out here. And so remember, we got a minus sign out here, so we can't let that mess us up. And so we put in 300 in for x. We have 0.002 times 300 cubed plus 0.01 times 300 squared plus 100 times 300 when I put in the upper limit of integration. Or the upper limit of integration. And now, right, you subtract, but minus a minus is positive. And so then we put in 0 in for x, all those terms are 0. So we have 0 plus 0 plus 0. You don't even have to write that out if you don't want to. Okay? Let me double check, make sure I haven't made a mistake. It's easy to make a mistake with all these decimal points floating around. And now inside the parentheses, this first quantity is equal to 5,400. The second quantity is equal to 900. And the third quantity is equal to 30,000. And 0 plus 0 plus 0 is 0. Well, what's inside parentheses is equal to 36,300. And that difference is equal to 11,700. 11,700 what? 11,700,000 dollars. Okay. And again, the reason it's $1,000 is because X quantity is in thousands. Okay, you're given that in the description of the problem. And so when I multiply 11,700 by 1,000, I have $11,700. And we're done. So the producer's surplus for this problem is equal to $11,700,000.